welcome to this workshop on design patterns. I'm Rishikesh and I'll guide you through this concept of design pattern for the next few sessions. Today, we begin with understanding what design patterns are all about, and we'll try and have an hands-on where we will actually go ahead implementing some of the design patterns. So without wasting any time, okay, let's begin with the concept of design patterns. As a developer, and especially if you're a developer who is working on object-oriented concept, it is today a must that you should be very, very comfortable with this concept of design pattern. Normally, what we do is we learn some programming languages. Then what we do is we go ahead with some data structure concepts, algorithms is what we learn. And a lot of times we do not really pay attention towards design pattern. Now, it will be an arsenal that will be adding to your tool set, which will make you a very powerful developer if you are aware of this particular concept of design pattern. And especially if you are an object-oriented programmer. You may be writing code in Python, you may be writing code in Java, C++, any of the object-oriented languages. If you're writing a code, knowledge of design pattern will definitely give you an edge or really make you a person who can write some very good solid code. What exactly is the problem that it addresses to, and what exactly design patterns are? That is what we plan to discuss today. So designing object-oriented software is hard. We all know that, especially when you're talking about a complex system. And designing reusable object-oriented software is even harder. And one of the basic principles of programming is do not repeat yourself. We want to create something that can be reused. And if we want to create a reusable object-oriented software, that's a challenge. Especially when we are developing a software and if you have deadline, we are not really paying attention towards the design. And I have seen a lot of developers giving a complaint, oh, let me finish with this task, what is on my hand right now, and let it work currently. I'll think about the appropriate design later. And the excuse that the developers go ahead giving, especially those are into software development, they go ahead giving, since the deadline is near, I need to make sure that it works. How it has been designed, neither my manager is interested, neither I am interested. But then this approach, if they follow, tomorrow when it comes to maintaining that particular software, it becomes next to impossible. Tomorrow, if you have to create a similar kind of software, it almost means redesigning the entire thing. We cannot use those earlier concepts that we had used to solve that problem in the next application. It actually makes the application such that it's difficult to modify in future, or it's even difficult to extend that particular thing that you have done and carry out some changes. It means you will have to redo the entire thing. So it's a challenge for an object-oriented programmer to create a software which is reusable. And what is this design pattern? This design pattern systematically names, explains, and evaluates an important recurring design in object-oriented system. You and me are not the first programmer who are writing code in object-oriented fashion. Now, object-oriented concept has been there around since late 60s and 70s. That means there is more than 50 years of experience that we have when it comes to designing object-oriented softwares. Now, all this experience has now been evaluated. They have reviewed that the way the certain problems are being solved. And when you develop software, you'll realize a lot of times in many different applications, you come across problems which are recurring. That means the same problem that you had faced in the previous application, in the next application as well, you come across with a similar kind of problem. So these are recurring problems that we come across. These are recurring problems. Not that you are the first one who has faced that problem. Almost every problem that you will be facing has been faced by some other developer earlier. Now, his experience does not become your experience, because now you start thinking as to how do I tackle that particular problem, because his experience may not have been documented. And that is the problem that we really need to address to. We need to design softwares which are reusable. We need to have experience that you had that should translate into my experience. Now, with this design pattern, all these things is very much possible. They systematically name, explain, evaluate the important recurring designs in object-oriented system with the goal of capturing the design experience in a form that people can effectively use it. That means what is the scenario, what is the problem, in what way we can tackle that particular problem, a recurring problem which several different programmers may face while developing different systems, especially in object-oriented manner. So those has been very well documented. and it will give you an opportunity if you can identify as a developer. Now, challenge over here is identifying what exactly the problem is. Now, if you can identify what exactly the problem is, in that particular case, this name of this particular design pattern now becomes a tool in which we can communicate with each other. As a developers, we can go ahead talking to each other. This is the solution to this kind of problem that you're facing. So we can identify and categorize the types of problems. We go ahead. The goal over here is to capture the design experience in a form that people can effectively use it. That means we are going to put across our experience in a way that my team members, my associate, my experience, they also can go ahead using it. And this is what design pattern really achieves. My experience becomes your experience now. The way I have gone ahead tackling that particular problem, if I document it properly, and it has been done properly documented in object-oriented in design patterns, so that is actually translated into a form that the other developers can go ahead using this. Now, what are the immediate benefits of going in for these design patterns? Makes it easier to reuse successful designs and architecture. And we are going to learn these various designs which are there. We are going to understand what is the design, what is the problem first, which design addresses to that particular problem, and how is that design, how is that solution providing, how is the solution working. So once we understand what are the consequences of it using it, so once we understand then it becomes easy for you to identify, when I come across such kind of problem, this is the solution which is available. Now, if I know this is a solution which is applicable, which will solve this problem for me, what is the architecture of that particular solution? And once I know what the architecture of that particular solution is, it is just a matter of reusing the same design every now and then. So you do not have to think about how do I tackle this particular problem in the most effective manner. Number of people have already experimented with that particular problem, and now they have devised a solution that will address to that particular problem. It's just like we have to use the same architecture and solve the problem on our hands, which is there right now. Expressing proven techniques as a design pattern makes them more accessible to developers in new system, or developers of a new system. So if you share, if you come across such a kind of problem, if this is the kind of difficulty that you have, this is a solution which is there, and so is the architecture of this, then you can just fill in the blanks in that particular architecture. The skeleton is already there with you. You just have to fill in the blank, customize it to fulfill your requirement, and your solution is ready. And not just a solution, it's a reusable solution that you have created. It's a proven model where all the pros and cons have been already weighted and so on. Design pattern helps us to choose a design alternative. You have more than one options which are available. I can solve this problem in this fashion, and that's precisely what we're going to do today. What I have decided today is, instead of me explaining you various design patterns, I have decided today to go ahead with the hands-on, take a problem statement and solve it with you. And we'll use some object-oriented language. Language shouldn't matter for you as long as you know some object-oriented language, be it Python, be it Java, be it C++, whichever object-oriented language you know. We'll take a problem, we'll go ahead solving the problem, and we'll see if I apply some design principles, how the solution improves, and then I can reuse the same kind of solution whenever in future I come across same problem. So there are challenges over here. What are the challenges? I'll explain as I go ahead. Design patterns helps us to choose design alternatives that makes the system reusable and avoid alternatives that compromise reusability. So we know why one design architecture is to be used, why another thing is not to be used. We need to have a justification. Why did I follow this particular architecture, this design to solve the problem? We need to have a justification. It's not that this came to my mind, so I'm solving this particular problem in this fashion. That should never be the case. We should be in a position to specify how and why have you selected this particular design. And that justification we can give, and we can ensure that the alternative that we have selected does not compromise reusability. We want to create reusable solutions. Design patterns can even improve the documentation and maintenance of an existing system. Actually, moment you specify this is a pattern that has been applied, the person who is going to review your code, he also has a very good idea what to expect out of it. So if you find some deviation from that, it is easy for them to understand where the things are not going right. And plus, for them to replicate, for them to document the things, that also becomes easier, provided they are aware of design patterns. So what is a design pattern? It helps the designer get the design right faster. We can actually experiment with a lot of things and we can make the things work. Probably that can be the right way of doing it also. But that experimentation is going to take a lot of time. Instead, if you're already aware for this kind of problem, this is the solution, then you do not really have to go ahead experimenting. You just have to, because there are alternative solutions which are available, you have to spend time, but the time will be spent in deciding which alternative is more appropriate over here. That's the only time that you will spend. And once you start implementing it, then you do not have to look back, because you are already clear as to what is the architecture for this particular problem, what is the architecture of the solution for this particular problem. The picture is already there. And plus, during the meetings, when maybe you are approaching a senior, you are stuck with a problem, you're approaching a senior, your senior may give you an idea as to how to solve this problem. But then that idea cannot be the entire architecture he goes ahead explaining for you. This design pattern becomes a tool for us to communicate and tell the other person what is the architecture that has to be used. Because if I use X design pattern, it has some architecture. If I use Y design pattern, it will have some kind of architecture. And if you approach me saying, sir, this is the problem that I'm facing, and if I tell you use X pattern, that means you are aware. If you are aware of design patterns, you know what is the architecture, how is this particular problem to be solved. That makes it much more interesting, and we will be understanding what these design patterns are all about. Now, for every pattern that we go ahead creating, each pattern describes a problem which occurs over and over again in our environment. Right. So each pattern describes a problem which occurs over and over again in our environment. That means when you're developing systems, there are problems that are reoccurring. It is not like that problem will be occurring only once. Even tomorrow in some other application, you will come across similar kind of problem. So if they are reoccurring problems, so it describes what are those reoccurring problems that you may come across while in our environments while you are developing application. And then what is the core solution to that particular problem? The first thing is identifying that there is a problem and what kind of problem it is. Second, there is a solution which is available for every kind of problem. And if you are aware of this particular solution, that solution is nothing but a design pattern. So design pattern doesn't just talk about the solution, it also talks about the problem that it addresses to. So when you learn any design pattern, the first question that you should ask yourself is, what is the problem that it addresses to? Why should I go ahead with this design pattern? How will it help me? What are the consequences of using this pattern, and what are the consequences of not using this pattern? So these are the questions that should always come to your mind. And when you weigh the pros and cons, and after that you realize it makes sense for me to put in this extra effort to implement this, and this is the benefit that I'll receive out of by using this pattern, then you will be more than happy to use that particular pattern. So every design pattern actually describes the problem which occurs over and over again. So it is talking about what is the problem. Then it talks about what is the core solution for the problem. And it's a template. You don't feel like it is a complete ready-made solution for it. It's a template. It's more like a guideline that is there. It's a template that is there for that kind of problem, that category of problem. Okay. And that template is such that we can reuse this solution a million times without ever doing it in the same way twice. Reusable. That's what we can do. Now, when we talk about this design pattern, the credit for this particular thing goes to, or credit for coining this particular term as design pattern goes to Gang of Four. And definitely not these four. There are different people who are there who actually capture the experience of developers across decades developing systems in object-oriented fashion, and they expressed it in form of a book, and that book was titled as Design Patterns. And today now we have this completely different thing called as design pattern that we go ahead using. It has become a must-know kind of skill set for every developer who is working on object-oriented programming. I'm not talking about other programmers, object-oriented programming. And object-oriented programming is here to stay for a long time even now. So this Gang of Four, as they are normally called as, these are these four guys who came across this book called as Design Pattern. The title of the book is Design Patterns, Elements of Reusable Object-Oriented Software. Now, elements of reusable object-oriented software, they went ahead expressing 23 different types of problems that we come across. They categorize those problems also into different categories, classified them into different categories, so that it becomes easy for us to understand what exactly the category of problem it is. And then once you understand the category, then what exactly the problem it is. And once you identify what exactly the problem we are facing, then there are ready-made solutions which are available. I mean, the templates which are available. And if I use that particular template, then my solution designing the code that I'm creating is reusable. I can develop it faster, and it is maintainable. It is understandable for everybody because I used a specific structure which is well known for everybody. So this, and there are obvious advantages. There are consequences of using a design pattern. That is also what we'll look into. So these are a gang of 4 who actually came up with this design pattern. The basic idea is like reusable chahiye, program to interface, not to the implementation. So decoupling karna chahiye, favor composition over inheritance, and it is actually using both composition and inheritance at a lot of places. But you'll find even in the number of patterns that are available, most of the number of patterns which are there, they prefer composition, and there is a combination of composition and inheritance. But many of the patterns will prefer composition over inheritance. And we will see as we go through these sessions of exploring various design pattern. So if you are really interested in exploring all the design pattern, this is the book that you should fall to. And although this book has been written several years back, it makes sense even today, perfectly makes sense even today when you're designing systems, and especially object-oriented systems. When you're designing, having knowledge about all these design patterns definitely will give you an edge, a confidence while you're solving problems, while you're designing systems. So thanks to this gang of 4, what they have done is they have captured all the experience of last 30, 40 years and presented in such a way to us so that we do not have to reinvent new solutions. It's about identifying the right solution and applying it. That is what we have to do. So it is improving our speed of development. It is making our code more standard, and it becomes easy for us to communicate with other people as well as to what is the architecture of the solution that we are trying to implement. So thanks to this gang of 4. So design pattern. What are the essential elements of a design pattern? First, the pattern name. The pattern name is a handle we can use to describe design problems, its solution and consequences. So if I say, today we're going to talk about a factory pattern. So when moment I say factory pattern, we know what is the problem that it addresses to, what is the architecture of that particular solution, and what are the consequences of it. So if I use factory, what will happen? What is the problem that factory pattern addresses? What is the architecture of the solution that it provides? What's an idea that it provides? And what is the consequence of using this particular solution? So the problem that is there, first part is the problem. So first is a pattern name, and that pattern name gives us an idea. The names are so very nicely given that immediately gives an idea, a hint, array, what should I do? The problem describes when to apply the pattern. Now this is the most critical part over here. It explains the problem in the context. It might describe specific design problem. Now, early days, even for you as a developer, even when you have explored all the design pattern, at times it is challenging for us to identify what exactly the problem is. And for my own experiences, applying in using the right design pattern, this is the most critical thing. Because once we learn the design pattern, you know the solution, you know the architecture, we can use that architecture. But a particular architecture design pattern is applicable for a particular kind of problem. The challenge over here is to identify what exactly the problem is. So if you fail to identify what exactly the problem is, then you go ahead selecting the wrong design pattern. It may happen initially, and I do not mind at all. Even if you make a wrong choice initially, you will get to see the consequences of making a wrong choice. So when you face the consequences of making a wrong choice, it is better than doing something very different and just playing around with it. Make a choice, apply it, see whether it fulfills your requirement, not apply the other pattern. It is not like somebody is going to give you a statement saying this is the problem, this is the pattern. Because the problem may be coming up to you in a different form. The problem may not be visible for you. With experience, you can identify what exactly the problem is. So challenge over here is to identify the problem. And once you identify the problem, then we know for this kind of problem, what is the pattern that is there. It is better to use some pattern than not using any pattern. Because if you use some pattern, at least one learning you will have, this pattern is not applicable in this particular scenario. So that's also an experience that you gain. If you use a wrong pattern in a particular solution, and then you over time figure out what was the right pattern, so you'll at least remember कि इस problem के लिए ये pattern applicable नहीं है. So I am of a personal opinion, it's better to use a wrong pattern than not to use a pattern. Use a pattern whichever is applicable, and then you figure out the consequences of using that particular pattern, because there are a number of patterns which slightly overlap each other. there is a problem. There are a number of patterns which slightly overlap each other. That means ये भी ये problem solve कर सकता है और ये भी solve कर सकता है. They are overlapping each other. So there is a challenge. अब दोनों भी solve कर सकते हैं. तो which one is better alternative which is available, better solution which is available for me to solve the problem? That's a challenge. But then you can figure it out with experience, looking at what is the consequences, what is the cost of using a pattern, and what is the consequences of using that pattern. Then you will realize, oh, this was not a better alternative. The other one that I had thought about, maybe it's more suitable for solving this particular problem. So you will gain experience only when you start applying pattern. So my advice to you is start applying patterns. The solution. So we talked about a problem, the pattern name that gave us an idea that it describes what is the problem, what is the solution, what are the consequences. And the problem is like it describes when to apply this particular pattern. If this is the kind of scenario that you have in front of you, then apply this particular pattern. And then there is a solution. The solution describes the elements that make up a design. So what is the hierarchy of classes that we should have, whether I should use composition, whether I should inheritance, what is the relationship which is there between the various components which are there, how do these collaborate with each other to provide that particular solution. So the solution will have an architecture, and this is an architecture that we should understand. And once you understand this particular architecture, you identified where it is applicable, you identified the problem, then you can apply that architecture. It's more of a template. I'll also give you a template form, and that template will give an idea, oh, how do I address to my current problem? Solution doesn't describe particular concrete design or implementation, because patterns like template can be applied in many different situations. Your problem may be different, my problem may be different. Different in terms of your business logic is different, my business logic is different. But the kind of problem that we both are facing is of the same category. So you will implement this template in a different way, I'll implement it in a different way, but architecture will still remain the same. The implementation, the fill in the blanks will be different, but the design will still remain the same. It's like a skeleton. The skeleton will still remain the same, and you fit up, it will act as a hook, and to that hook you'll place your codes. But where to add, the hooks are already given to you. You just have to attach your code to those various hooks, and your application will be ready. Your problem will be solved. Instead, the pattern provides an abstract description of a design problem. It's an abstract description of design problem and how general arrangement of elements, classes, and object will solve it. So there are a number of things which are there, which are collaborating, number of elements in this solution which will be there, which will be collaborating with each other. They will be having various relationships, responsibilities. This particular element should do this. This particular thing should do this. There is a reasoning why those elements have been introduced inside this solution. And they're all going to collaborate with each other. Some of them will be classes, some of them may be objects, some of them may be abstract classes, some of them may be interfaces, whatever it is there. So they are all going to collaborate with each other to provide a solution. So template has been given to us. We have to use that template and apply that particular design architecture is just a design architecture to the problem that we are currently facing, and customize it to fulfill your own requirement about your problem. The consequences, this is something very important. It's a trade-off of applying the pattern. What if I had not applied the pattern? Was it better? What if I use this particular pattern? Is that better? And what is the cost benefit analysis that we'll do? If I had not used it, if I use it, is the amount of efforts, does it really justify to put in this additional efforts for applying this pattern? We should be in a position to justify it. If you cannot justify, then probably you may not use that particular pattern. The problem may not be that complex that requires you to use a pattern. So forget, just solve it the way you have been doing. So you have to have a trade-off between applying and not applying. If I apply this pattern, what are the benefits? If I don't apply, what is the cost? Consequences are critical for evaluating design alternative and for understanding the cost and the benefit of applying the pattern. Cost could be like the efforts that you have to put in, the additional number of classes and interfaces that may come in our design, that could be a cost. And benefit could be, it is reusable, it is easy to understand, correct? And it is scalable, so that there can be advantages of it. Consequences of software often concern space and time trade-off as well. Space and time. So more number of objects, more number of classes, you have to actually give a thought. Does it really make sense for me to have this additional set of classes and hierarchy of classes when I'm implementing this particular pattern? The design patterns that has been given, this gang of 4 very beautifully have classified these patterns. They have been classified this pattern based on 2 criteria. Ek hai scope and second is purpose. So on both this particular thing, they have classified all the patterns which have been given. The first criteria called as purpose reflects what the pattern does. The pattern can have either creational, structural, and behavioral purpose. So today we are going to focus on these creational patterns. Okay, and I'm going to tell you what these creational patterns are, and what's the real purpose of using this creational pattern, what kind of problem does it addresses to, and we'll take two problem statements and we'll do an hands-on, we'll implement a solution for those two problems. And I want you to contribute the ideas that you have in your mind. How do I solve this particular problem? And then we'll go ahead improving that design as we go ahead. I have some ready-made solutions as well, but then I had taken a poll. I asked students, how should we go ahead? And most of the students said, sir, if it's hands-on, we'll appreciate. Even if we cover up less number of patterns, let's do a hands-on, let's take a problem statement and then go ahead solving the problem statement. And then over a period, evolve to use a pattern and see how does it change the overall design, what advantages that is provide us to solve that particular problem first. So we have to see firsthand, what is the problem of not using a pattern. So if you use it firsthand and understand what is the problem of not using a pattern, then you'll appreciate what's the advantage of going in for a pattern, design pattern. So the first criteria is that of purpose. It reflects what the pattern does. So creational pattern are concerned with the process of object creation. So we'll start off with the simplest one, object creation, because that's something which is so very fundamental, so very common. And for that also, there are so many patterns which have been given, which will facilitate creation of object. You just have to understand which pattern will I use for construction object and when. Structural deals with composition of classes and objects. And third is behavioral patterns, characterize the way in which classes and object interact and distribute responsibility. So this is part one of our seminar. And part one, we are going to focus on creational, part two on structural, and part three on behavioral. So it's a 3-part series that we're going to have, wherein I'll try and give you glimpses about various design patterns from each of this particular category. Today, we're going to focus more on this creational pattern which are there. The second criteria for classification of design pattern is the scope, which specifies whether the pattern applies primarily to classes or to objects. Now, when there are classes which comes into picture, keep one thing in mind. Whenever there are classes, hierarchy of classes, there is inheritance. And if the pattern applies to object, then it is composition. Okay, and composition is preferred over inheritance. You will find less number of patterns using classes and more number of patterns using objects. Remember that statement that I showed you was prefer composition over inheritance, and you'll understand why am I saying so. Now, not me, gang of four said so. Okay, even if you go ahead with effective Java programming, there also Bloch talks about the same thing, prefer composition over inheritance. And we'll see how and why it really matters. So second criteria is the scope, which specifies whether pattern applies primarily to classes. Keep one thing in mind. When it is about classes, there will be when it is about classes, there will be inheritance that will be a major idea. And when it is object, it will be the composition which is the major idea. It's not like the other place I will not have inheritance and the first place I will not have composition. No. The primary idea is using inheritance. And when it is the scope specifies whether applies to the pattern applies to the object, the primary idea here is composition. Just keep that, mark it and keep it. When the scope is about objects, the primary technique that I'm going to use is that of is that of composition. And the scope is that about classes. The primary concept that I'm going to use is that of inheritance. So the class pattern deals with relationship between classes and their subclasses, hierarchy, inheritance. The relationships are established through inheritance, so they are static, fixed at compile time. Main design idea is inheritance. So keep that thing in mind. If I'm creating I'm talking about a pattern, and if that pattern is the scope defines that pattern is applicable to classes, so the primary design idea over here is inheritance. That's the primary design idea, inheritance. And if it's object pattern, that deals with object relationship which can be changed at runtime and are more dynamic. And this is the beautiful part of it. You can add behavior, you can remove behavior. Once you design a class, it is static. It will have the set of behavior. You cannot alter the behavior of a class, isn't it? And even if you extend that class, that's again fixed. That cannot change over a period of time. For every new behavior, we have to extend and create a new class. From existing class, you cannot get different behaviors. Object-oriented pattern can address to that. That means two objects of the same class can give you different behavior for the same service. Something like this can be done. And which is, first glance, it looks like, hey, how is it possible? If these are objects of the same class, they will have same behavior. But objects of the same class can also have same behavior for the same method. Such kind of very interesting solutions it can provide. So object patterns deals with object to object relationship, which can be changed at runtime, and they are more dynamic. predominantly use association as the main design idea. So it's not composition, it's not inheritance, it is composition or association. When I say association, various types of association we can talk about. So when we talk about whether the association is strong or whether it's weak, based on that degree we can say whether it is composition or not, but it's a kind of composition, or rather composition is a kind of association. So here we are going to use association as the major idea. We're going to use association as a major idea. Almost all patterns use inheritance to some extent. So if I'm using association or if I'm using composition, that doesn't mean there will not be any inheritance over here. The major idea, the main theme over here is that of association. Now, if you look at this category, and these are things that we are supposed to learn. So based on purpose, we have creational, structure, and behavior. And based on scope, we have class and object. So what I plan to do is, for almost all the three categories of patterns, I'm going to take, anyway, in the class scope, there are very few. So I'll take one from the class scope and one or two from the object scope, one from this class scope and one or two from the object scope, one from the class scope, one or two from the object scope. So there are in all 23 design patterns that have been suggested by the gang of 4. And when you talk about Java EE, they have extended this to 51 different design patterns, just a variation, slight variation. Variation aa jaye, they are all, but fundamentally, these are the 23 patterns that we have. And based on that, different technologies, they have customized it to address to more specific kind of problems. So there are slight additional variations. They are just like specialization of this design patterns itself. But if you are aware of these design patterns, take my word, you have a ready-made solution for most commonly occurring problems. You may be under impression that you are the first one to face that problem, but that's not the real case. Similar problems have been encountered by developers for the last 50 years several times. And if you are aware how and what is the best technique to address to this particular problem, what remains is just to apply that particular pattern and get your work done, create a reusable, maintainable kind of solution. So these are various patterns, and this is the various classification. And if you look over here, you'll understand, prefer association or composition over inheritance. So it's not like here there will not be any inheritance. Even in object scope, there will be inheritance, but major idea over here will be association, composition, and here it is inheritance. But there are very few patterns which actually go ahead using inheritance, and most of the patterns will go ahead using association. And the major idea of association is composition is what they will go ahead using. So we'll focus today on creational pattern. My objective is to take a hands-on on creational pattern. So we have enough time. So we will implement some creational pattern. Right? I told you one from the class, another from the object scope. So when I take it from the class scope, the only one that we have is factory material. So we have to discuss it. Okay. When I talk about object scope, I'll be taking few from the object scope. And I'll avoid some patterns just because it may confuse you slightly right now. So I'll take something which are quite different from each other. So if they are overlapping too much, it will be difficult for you to differentiate between them. So I'll take ones which are slightly different than each other so that there is no overlapping and you can very easily figure out when which is applicable. But whatever patterns that I discussed during this workshop, say around three sessions, we can at the most have 6-7 patterns, 8 patterns maximum. Because the initial discussion will not be there now in the next few sessions. In the next 2 sessions, we can have more design patterns that we can implement and see. But then it will not be possible for me to discuss all of them. But if you understand the need, if you understand what problems does it address to and how this will create a solution which is maintainable, it is up to you to explore these additional patterns. Or then you can come down at Impetus and you can join a course on design patterns. Here, creational design pattern. What did we say about creational? Creational patterns abstract the instantiation process. Instantiation is construction of an object. So they will abstract the instantiation process. So how the objects are being created, that will be abstracted out. The client will not know how the object is being created. He will be supplied the object. He will not know how the object is actually being created. They help to make a system independent of how the objects are created, composed, and represented. Client needs an object, so I'll give you an object. I'll give you an object that will fulfill your requirement. You please don't be bothered as to how that object was created, how it was composed, how it is internally represented, as long as your requirement is being taken care of. So we're going to abstract the instantiation process. How that object is to be instantiated, that we are going to abstract out. Sometimes construction object is very complex. There are a number of parameters that have to be passed to it. At times it so happens, the time that is taken for construction object is quite too much, and you want to save on that particular time. So the configuration object, the number of parameters that have to pass, the initial setup is costly. So there are so many different reasons why I would like to abstract out the instantiation process. Sometimes we don't even know what object is to be instantiated. If I do not know what object is to be instantiated, how are you going to write new statement? Because even if it's C++ or Java, if I have to create an object, you'll have to say new some class name. And if I do not know what is the object that I have to instantiate, then how am I actually going to create an object when you're not even aware which object is the best suited to solve my problem? So if you're not aware about the class that you're going to use to instantiate, so you better abstract it out and tell the system, you don't bother, you tell me what you want, I'll supply an object, I'll abstract out the entire instantiation process. I'll not let you know how the object is created, composed, how it is represented. You wanted it, I'll supply it to you. You don't be bothered. So your client will get an object that he wants, and he'll not be bothered about how that object was instantiated, it was created, it was composed, how it is internally represented. Everything we are going to abstract out from the client's view. Client is the program that is using my object. Client is the program that requires my object. The class creational pattern, that's what we are going to start off today with. The class creational pattern, and there is only one class creational pattern. Okay, the class creational pattern uses inheritance to vary the class that's instantiated, whereas an object creational pattern will delegate instantiation to other objects. So we'll see both of them. We'll take one example of class creational and maybe two examples of object creational, but at least let's see how much time we have, because I'm not going to share a ready-made solution to you and tell you, oh, this is how the pattern is, which we could do later stages. Maybe in the last third session, we can do that, because by that time you'll have an idea and you'll believe me that this makes sense. So in the third session, probably we can discuss more ready-made solutions. Today, we are not going to do that. Today, we'll take up a problem, solve that problem, even if it means solving only one problem, be that. But we will solve a problem and see how it is beneficial. The class creational pattern uses inheritance to vary the class that's instantiated, whereas object creational pattern will delegate instantiation to other objects. So other object will create an object and give it to me. Delegate, composition, delegate, and it will supply me an object. Whereas class creational, there is a concept of subclasses that will be there. So inheritance is something that I'll be using. It uses inheritance to vary the class that's instantiated. So the subclasses, they will supply me the instance. And we said code for interface, code for the super type. It can be interface, it can be abstract class, whatever it is.